Hi, good evening, everyone. This is Ayub from Immersive MedTech Solutions. So we shall be just starting the webinar in a couple of minutes. Let others also join. So around 6:30 to 6:33, we'll be starting the webinar. Please let me know if I'm audible.
Yes, you are.
Hi, so I shall be beginning this webinar. Just let me know if my screen is visible. Yeah, I hope my screen is visible. So good evening, everyone. I welcome you all to this webinar focusing on VR-based medical image segmentation using Elucys Next by Realize Medical. So in this webinar, we shall be focusing on the advanced soft tissue segmentation and VR modeling with Elucys Next. Why we have chosen this topic is because everyone who is familiar with medical image segmentation must have gone through orthopedic segmentation, which is very much easier. We can directly rely on the threshold scales, and working on the threshold values, we can easily segment out any orthopedic data set. But when we talk about any soft tissue segmentation, so identifying the soft tissue parts from the nearby noises, we can say, or nearby orthopedic region that we are working on, it's quite difficult. So to cover that part out, what we have is we have the VR-based segmentation that is powered in Elucys Next. So we, Immersive MedTech, are official distributors of Elucys Next in India. What this software does is, whatever we must be familiar with normal medical image segmentation techniques in any 3D image processing software. The same is now being relied in the VR space. So we have now huge spaces for our data set to be worked on. We can combine multiple data sets, then we can have different sets of designs to be created directly in VR. So we have all the particular 6 degrees of freedom for our working. The particular software is both desktop based as well as VR based, but to use its full potential, we rely on the VR based segmentation methods. To cover out the image based segmentation, we have the DICOM CT, then CT images, micro CT images, MRI images. Even if we need to consider any Nifty image or any other image data set, that too can be imported and we can do the 3D reconstruction out of it. The 3D reconstruction is further being covered in two methods. So either we can select a threshold base or we can directly do the sculpting in the VR view itself. So to give a general overview how the VR plays a crucial role in medical imaging is, whenever we are working with a medical imaging data set, the foremost problem that we used to face was whenever we are working with any 2D slice of images, there are a lot of noises. There's very difficulty in distinguishing the data set from one point to another. And then what we secondary have is whenever we are working with such data set, there might be some sort of losses while we are doing the 3D model conversion from a single 2D image. So to cater that out, what we have is we have the medical image segmentation VR based, wherein we can directly mark out our specific region of interest, working on the specific points. Then to do the refinement of that region, that can be done. Then smoothing of the particular parts can be done. And this way, any clinician can get a very good spatial understanding of whatever anatomy that he or she needs to work on. Now, coming on to the interactive imaging, how do we do that in software like Illusis? So it's quite simple. Let me just choose a pointer. Yeah, anyone? Yeah. So what we do is we choose a pointer over here. Sorry. Uh, Whenever we have imported the data set, once the segmentation is done, so segmentation basically relies on to identify different parts in any CT data set. So for example, this particular CT data set also has the particular femur, then tibia, then even if it has an implant positioned within the data set itself, that too can be highlighted out. Then we have the nearby muscular region, the skin part. So each and every part can be easily distinguished out, and then whatever part that we need to work on, we can select on that. If we are required to move one part from one position to another, if we are required to do the mirroring of the particular part, if we are required to do the slicing of the part, all that gets completed in a single click operation. We can have multiple clipping planes, so even if we are required to do multi-planar reconstruction, that too is a possibility in a very efficient way. Apart from this, even if we are working with a 4D CT image data set, so to work on with the time offset data set, that too can be done. We can easily see how the series gets changed in a particular time offset data set value. Then apart from that, even if we need to combine the CT and MRI data set of a same patient, that's very easy over here. We have certain blending options that can be selected out, which I'll further discuss in the live demonstration part after this particular presentation. How we are using it in a clinical workflow is once we have imported the data set, so this will be the initial view that we would be getting. So the particular rib region is the particular segmented part that we have done. But before the segmentation has started, we will get a single slice view. Either we can select the view as coronal, sagittal, axial. We can change the view, we can interpolate the views, or else we can rotate it in any direction. Furthermore, the size of the data set, the data view that we're working on can also be increased or decreased as efficiently as a single click operation. Apart from that, even if we need to do certain other modifications, that too can be done. If we need to do the cropping and all of the data set, that too can be carried out. So this is the view tab that we get. Here, you might not be able to see very clearly, but what we have is whenever we are doing the particular segmentation, the first point that we get is the image threshold based segmentation. Here are two further options. We have use threshold addition and use threshold subtraction. Here we can set out the range. Accordingly, we can just slide on this slider and we can select out a threshold range that we need to do the segmentation. Then to remove out the small noises that are present in the data set, we can click on this reduce noises option. And here we have an apply to active structure. So this is not very clear in this particular picture, but I'll just show in the live demonstration how we basically do and carry out the segmentation for. Before these all our parts are to be done, we need to first create a structure. A structure means we are identifying and creating a separate mask over which we will be doing the segmentation. Here, multiple masks or multiple structures can be created, which can also be later on exported either for STL files, OBJ files to be viewed in any 3D viewer, VR viewer, or even if we need to do the 3D printing of the same. So the same task can be done in a very efficient way. It has a very user-friendly interface, so even a beginner can learn the software in 1 to 2 days and get proficient with the tools. We have certain tooltip directories. So since it's controlled by controllers, left and right controller and the VR headset, how to get familiarized with the controller settings, how to optimize our data set, that is very easy in this software that I'll further showcase. Then how we are basically delivering the particular task is, for example, if we need to do a whole spine segmentation that can be carried out, which can be further splitted. So we can create multiple clip planes and okay. So, and along the particular clip planes, we can just do the particular structure creation. We can do the particular mirroring of the surface along any clip plane. Then we can do extension. If we are dealing with a hollow heart CT model, and for example, the particular patient has a VST defect and surgeon needs to do pre-surgical planning for that. So that too can be done in a very efficient way. We can directly bring in the particular CT data set. And once the particular CT data set has been brought in, we'll do a single click operation of segmentation. We will highlight that particular part out. And once that is done, we will hollow out the structure if we are required to do the 3D printing of the same. I have certain test cases that I had earlier on segmented in and that were converted into 3D printed models that I'll further showcase after this presentation part. Then there are multiple benefits that we and one person using the software might get. So it starts with directly learning about the particular segmentation methods in the VR. So if there is any beginner or user, so he or she can easily learn directly going inside the particular software to interact with the data set, how to split up different parts that are being present in this data set. And this ultimately results in better patient outcomes because earlier the time of segmentation was quite high. And to reduce that out, this particular method is very much recommended. We can specifically highlight our region of interest. For example, if we are interested in aorta, so we'll go to directly to the aorta and we'll mark it up. We need not to mark other parts like myocardium, then left right ventricle, left right auricle. So that are not readed. So whichever part is required, we can easily highlight that out and the segmentation gets reduced within 1 minute. After that also, we have certain levels of segmentation. So we have when medium, then high, then ultra. So these are different settings that we can select and one is low. So generally the preferred method is medium and high because higher the value will go. For example, with an ultra, so we will be requiring a decent workstation which has compatibility with the hardware that we are working on for efficient segmentation. Now, discussing about some of the practical applications. So the cardiac CT segmentation is one such application. Then we also have a stent planner inbuilt in our software. We can do the easily the stent planning. We have certain particular jigs that are available that we can further manipulate and worked on inside the software. Then we also have careful design. So we have a 3D free 3D designing tool. So we can set out the control points and according to the control points, we can design any design that we are required for. Even if we are required a solid structure like prisma, sphere, that can also be generated out, or we have a free surface option. So whatever points that we would be selecting, it will directly convert that out into surface. It can also be used, for example, since this is focused on majorly soft tissue segmentation, but even if we need to, for example, design a cranial plate, that too can be carried out and we can easily do the segmentation. We can just select out the control points and design it accordingly and later on convert into printable STL files that can be 3D printed out. Then it is also used for doing the training simulation and educational purposes where the software can be directly brought in and whatever CT dataset, whatever MRI dataset that we are working on, the particular any student who is working on the dataset can easily identify the particular diseases, even if the particular dataset is having a tumor within it. So it can also be easily highlighted out and segmented out from rest of the parts that we are working in. Then we have directly DICOM to PR process in Illusis, which is very simple. Whatever segmentation that is being carried out, we can do it easily in the particular VR headset. But one more advantage that we get is we can connect it to our remote system. For example, if we need once the segmentation has been completed. So there is one file .eep file that is the proprietary file of Illusis software. What we can do is we can load out the particular EEP file once we have installed the Illusis software directly in the VR headset. So any Android system is compatible with the Illusis Next software, Illusis Next APK file, APK software that we can directly install, and we can run the particular EEP file within it. So even if we need to do the remote visualization, so surgeon can be in the surgery in the surgery and still visualize the whatever segmented part that we have done. Apart from it, we have the particular collaboration method. So for example, if one user is working in the particular segmentation VR segmentation environment in Delhi and other needs to connect it in Mumbai. So what they can do is they can come in a single virtual environment. They can type in their inputs. They can do the segmentation. So there are different methods If we enable only the engage mode, so the segmentation won't be done, but if particular surgeon needs to highlight any specific point, that too can be carried out. Apart from this, it's also used in various publications. So I'll just remove my pointer. Yeah. So here are certain publications for which the Illusis is being used. So one can check over here, for example, for dimensional right ventricular outflow, so tract segmentation that is done. So there are multiple case studies that one can go through how to basically use the software in carrying out the segmentation. And it's a very detailed library along with the video. So we have YouTube videos of the same, how to carry out the segmentation, what's the easiest way to carry out the segmentation, and how it can be done. Then furthermore, we'll just directly switch on to the live demonstration of the software. Meanwhile, till here, if anyone has any queries, they can let me know. I'm just starting the software. It takes some time. So I'm also switching on my camera to show the VR headset. So this is the particular. So this is the particular VR headset that we have. Here are the particular controllers. I think there is some push. Uh, Dr. Rahul, the particular costing and all will be discussed by sales team, so you can just share your contacts and I'll ask my sales team to contact you. Thank you. So I'm just continuing with the live demonstration. Meanwhile, any other queries apart from costing? So thanks, Dr. Riddhi, for sharing your contact details. I'll ask my team to contact. Uh, so I'm just opening my software. So this is how the software interface looks like. So here you can see there are two modes of doing the particular segmentation. The first one being the create mode, wherein we can directly go inside any view. We can do all, we are given with all the set of tools. There is no limitation, and we can carry out the particular segmentation later on if we are required to do the modeling and all. So it can be done in the create mode. Then the other mode that we have is the engage mode. So if we are ready with an EEP file, we have already worked on any project in past, and we need to directly open the particular project. So in that case, the particular a project can be directly loaded in. We are limited with some of the features, like we can still do the segmentation and all, but we can just highlight the specific parts. For example, here we can whatever intersection is part is present. So this was a basic segmentation, that was a direct segmentation that was carried out. This is just for engaging, and if someone needs to put up certain points, that can be done. Then if we need to, there are multiple objects, we need to move it in the particular 3D view, that can be carried out. So these are the parts that we have. Then if there are multiple users and they need to connect in a single view, so what they can do is they can just click over here and checking. After this checking connection is done, whoever has the same license key can connect and can come in a single window. And once all the particular users are in single window, they can put their inputs. Apart from this, we are also given with three methods of recording. We can do particular rotational series recording. Here we can set out the field of view. We can select out the rotational axis, and we can check how the particular rotational preview would look like. Once it is done, we can just click on export, and we can directly do the rotational image series export. Then if we need to do the whole recording of this particular video. So for example, if we are needed to record the whole session, whatever segmentation part, right from beginning of the DICOM import to segmentation to modeling, we can click on this start video recording and we can start the particular segmentation. Then coming back how to basically work in the particular Illusis software using a create mode. Because a create mode is generally required to efficiently work with all the set of tools that are present, and there's no limitations over here. I'll just enable my camera. You can see this is the particular VR headset that I have. Here I'll just connect it. Once we go into, hello, just give me a second. So this is my right controller that I have. Just give me a second. Sorry, actually, the voice was audible in the headset and my earphone as well, so was causing some issue. So I'm just connecting inside the window. Here I have the Illusis window open. To click on create, what we do to create a new project, we just click on create. Now we can scan in the particular DICOM files. So how we do that, we will be selecting the DICOM folder that comprises of the image. Whatever is our image type, we can select it from here. For example, if we are generally carrying any JPG images, text, TIFF images, text, so that too can be. So once it is done, what we have is we will be scanning the entire folder. So so whatever segmented, whatever DICOM image series that, whatever series that we will be having in the particular folder will get scanned in. Then we need to save the particular project as whatever name that we are required for. Before that, this is my left controller that I would be using to control the environment in the VR view, and this is my right controller that I would be using. There are certain buttons over here. So this is the A and B button that I'll be using, and here is the X and Y. Why it is important is because once I'll open it in the particular VR view, what we would be getting is we need to get familiarized with the tool, because if we aren't familiarized with the tool, we won't be able to do the segmentation that efficiently. Apart from that, this particular data set also carries a 4D city image of the same patient. So that's why it takes time for such data sets to be loaded. And once the particular data, all the particular series of the data set has been loaded in, we can bring that in. And here, what other option that we have is in any software that we generally work on, we can only use one series or two series at max. Here we can choose n number of series. The only restraint that we have is we need to have a powerful hardware for it. Currently, I am working on a remote laptop, so it is not that hardware efficient, but it does the job for me. So it scans the folder. The scanning of folder may take from 2 minutes to 5 minutes, depending on the data set that we are working. For example, if it is a single series of data set, it hardly takes 30 seconds. But if the data set has multiple series within it, so it will take generally higher amount of time. Once that is done, you might be seeing a small settings tab in the Illusis software. We would need to be going in this particular tab. And once we go over there, what we'll be doing is we will reboot the particular system. So in that case, what it will take is the system would get connected with the particular a VR headset that we are using. And once this is connected, we'll come in a single window where which in which we need to use the particular software for. So this. Let me open another series. Meanwhile, since it's taking some time, I'll open a single series of dataset over here. So we can open multiple windows in a single system. Here, it has automatically detected my XR system. So now whatever we would be seeing, we can directly work it on. So I already have the particular data set loaded. So what we can show is we can show with this particular Siddhi. This data set is fine. It's a single series of data set. After this is loaded, I'll show the particular 4D data set that needs to be worked on. It will be running in the background meanwhile. Here, once a particular project that we have already worked on gets loaded in our loading view. And now what we need to do is, first of all, we need to click on this follow point of view. So what the particular follow point of view does is, whatever I would be seeing in my VR headset, you would be seeing the same in the screen. So I'll just delete the older segmentation so we can start with starting. So this is the general view that we get. I'll just click over here, going inside the view. So this is my right controller that I would be using, and this is my left controller. The first and foremost thing that we need to do is we need to click over here in the particular uh, B, B keystroke in my right controller, and once we click over here, so you can see there are a lot of tabs that are coming in front of us. So what we need to do is, the first and foremost thing is we need to click in this configuration. We need to select this quick surface, and once this quick surface is done, we take a 1 hand distance and we select the particular window over here. So what we have an option is we can just uh, click the particular trigger in my left controller, and I can hover it around, I can move it in any direction, and we can see the particular data set in any cross section that we are required for. So here we can also rotate it. Here we have another option to increase the size. So even if we need to see it as a larger window, that too can be done. If we need to reduce out the size, that can be done. So it gets fitted in my working window. Then if we need to move it around this particular window without rotating, that can be selected from here. So we have a controller option over here. In this through this controller, I can just select out the outputs. So to get familiarized with the tooltips, we have what we need to do is we need to click on the Y keystroke in the left controller. And once we do that, we need to go inside the settings. And here are tooltips. So once we click on this tooltips, so you will see the magic. So here we have all the options that we are required for. So for example, if we are drawing something, here's the stylus button that is corresponds to the right trigger. Then we have the particular B to open the stylus mode. That is the particular menu that we need to be using. Then we have this navigation window. So we can use navigate around the tools if we need to rotate it along one axis, if we need to rotate it around other axis, that can be done. If we are rotating around central axis, so that can be selected out. And this is the central axis around which the data would be getting rotated. Once we are done with this, if we need to drag and drop it up and down, that can be done. And if I just go and turn my head down, so I can see the data set more clearly in the volume rendering. Coming on to the volume rendering part, so this is one such good feature that we have in Illusis. We can directly go in the particular menu option by clicking the Y keystroke in my left controller. And here we have certain options. So whatever projects that we have worked on in the software gets recorded over here. So at any time we can open any project. Then we have the navigation window. So to move the data set through this particular window, so it can be done over here. We can select out the particular axis, the coronary sagittal transverse axis. Apart from this, this is the particular clip plane that is initially selected to hover this data set. So that can be selected out, or we can have multiple clip planes. So if even if we need to do multi-planar reconstruction, we can just do it like this, and we can easily do the particular modeling. We can at any time enable and disable it. So this will be much more clear once we do the particular segmentation, how this particular clip plane would act and work for us. So I'm just deleting it for now. Then in the images section, you can see there are a lot of options that we are having. In this particular data set, there were three series of data set that were loaded. So this is the particular with 40% dilution, then we have 70%, and then we have the 70% for credit. So if we select over here, we can just change the series of data set that we are working in. And apart from that, what we can do is we can click over it as live image. And here we have a blending option. So there is one primary image and one secondary image on which we work on in this software. Here we can select in and we can blend in the data set. So this way there will be much more clarity while we are working with the gaps or even at the boundaries, so we can have the most efficient surface to be regenerated. Apart from this, if we are considering the volume rendering, so what we can do is we can click over here and we can generate a volume rendering directly of any part that we need to work on. Here the data set is not very clear, so what we can do is we can, in this option, we can select the part that is required. And even if we are not satisfied with it, what we can do is, so for example, if I select a CT coronary artery, so I can have a much more clear picture of whatever DICOM data set I was working on. So even once the segmentation has been completed and we have worked inside that data set, we can do that easily. Before even doing the segmentation, we can still go to the planes option, and in the planes, we can cut around the plane. So for example, if we need to cut it over here, so that can be done. If I'll just click and add another plane and I'll just enable this one. So you can see we can how efficiently we can model and we can cut along the particular axis to see the internals of the surface. So at any point we can cut, we can have multiple planes to be cut out. So we can directly visualize the data set from the DICOM itself. But you can see there is a bit jitter while we are working with such view because we require around 32 GB of RAM in system while we are working with such data sets. But the current system configuration is around 16 GB. So that's why there is some jittering that is going to occur. So what we have is for that, we can select over here, and here we can select a ghost mode of operation. Now, whenever we will do up and down for this data set, it won't jitter, and we can easily work across the data set. We can do the visualization. Here we can select the points to highlight the specific region. So here we can just model it, and we can select a particular window and level to further see the data set changes. So for example, if it's a soft tissue, I can just highlight over here and we can select the particular soft tissue. So here we have direct options through which we can select and we can further work on the data set efficiently. Now the next part comes is the model. So you can see right now the particular structure generation is empty. To start up with the segmentation, what we have is we need to click on this plus sign. Once we click on this plus, so as told, so we have four levels of segmentation. One is moderate, one high, ultra, max. We generally prefer using high and ultra max to max because even at ultra, it will take time to do the segmentation. And high also creates a good and accurate model. So once we do this, we just need to click on create. Here we need to toggle on this both 2D and 3D enable. Now, one might question that nothing has occurred. We have just clicked on it. Yeah, so we haven't done this, we haven't started the segmentation yet. To start the segmentation, we need to click on this A button. Then in the modeling tab, we have the addition option. Here now, what I was showing in the picture in the PPT earlier, here is the image threshold window that we are having. Here is the use threshold add and use threshold subtract. Then here is the one display threshold. What this display threshold does is it will highlight the particular region. So the pink region that you would be seeing, it might be not that clear in the video, but I can pretty clearly see the particular pink region over here that is getting highlighted over. We can select a threshold range, and once that is done, we can start doing the particular sculpting. So if I move my particular pressing my trigger, if I move it forward, so the brush size decreases. If I move it particular backwards, so brush size increases. Similarly, if I change if I click this left trigger. So the mode of operation changes from addition to subtract. How it happens is, for example, if I'm doing the particular modeling, so I can just click over here. I can select out the parts that I need to model. So we can easily do the particular segmentation. We can increase the brush size to do it a little bit faster. But one might question that there are a lot of nearby regions that are also getting highlighted out. So this is how the particular operation would do. Once we have generated the particular model, so once we are finished with it, the particular green to orange. And now what we'll do is, whatever part is undesired, we can just remove that out. I'll just reduce out the brush size. I think there's some network issue. Can you see my screen properly? Someone can answer. Sorry, there's some network issue at my end. So I hope my screen is visible now. So what I was showing is we have this left and right controller over here through which we operate inside the dataset. So for example, this particular part isn't needed. So I'll just increase the brush size and I can directly eliminate that particular part out. So we can do the segmentation very efficient way, and it hardly takes around 2 minutes to properly segment out a cardiac anatomy. That's quite difficult while we are working with the traditional approach. So we can easily select out the part that is not required. And the same mode of operation can also be done in a desktop version. So even if we aren't very familiar with the VR headset at once, if we need to do the starting of the software in the particular desktop version, so that too can be done, the segmentation can be carried out. But I generally prefer the VR mode because it's much more time efficient and we can easily do the segmentation. And once we are familiarized with the control, then even if there's any beginner that's using the software for the first time can easily do the segmentation. This is how we can remove out the particular parts, and once the parts have been removed out, and there are multiple methods to segment this particular part from this. So what we can do is we can do a particular shrink operation, and in this particular shrink I can reduce out the noises that are being present in the dataset, and later on while we are growing the aorta, so that can be done. That can be further splitted. So if we need to do a separate segmentation for the particular uh, aorta, so that can also be carried out, and uh, that can be further concluded. So what we do for such cases is we use a AI-based segmentation. So we have AI-enabled segmentation, and once we get a general mapping of the part, we can directly work on it specifically. So here I'll just select out the region, reducing out the precise and mapping it again. So this way it gets mapped, taking out the operation. And this way a particular heart model gets modeled within 2 minutes. It's a very efficient way. And now whatever part is being remaining, for example, the aorta openings, I will just click over here. This way any part can be done. And if I need to reduce out the noises, I can just click on this single click operation. All the small noises that were present gets removed. And later on, the other ones that were quite large can be manually be removed from here. I'll just select as operation as remove, selecting the operation, selecting the threshold size. Here, one more option that we have is, for example, if it's lying in this particular threshold region, I can just select it out. And then if I just change the threshold value over here and I add the particular region, so we can directly model the specific part that is being required. Here, it hardly takes some time to do the segmentation. Sorry, system got disconnected. Sorry, the system got disconnected. I hope my screen is visible. Just give me. Yeah. So I'll just quick surface it to my viewpoint once it is done. Now what we can do is we can further do the manipulation, we can do the particular modeling, we can add and reduce out the noises. So this is a general way to segment out any soft tissue. One more thing that we can do is we can go in the operations, and here we can hollow out the entire structure that we are having. So to do the hollowing of structure, so whenever we are working with a single structure operation, so we have options. So we can duplicate the entire surface. We can expand the surface by some certain extrusion. Then we can do the shelling. Shell means to hollow out the entire surface that we are working on. Then we have smoothing of the particular surface. We can just select it over here, and once the execution has been done, so it will smooth out the entire surface that we are working. And once it is done, we can check the surface over here. Then again, if we need to do the particular uh, hollowing out the structure, we can select out the expansion length. Once it is done, we'll just click on execute. Yeah, now you can see another structure has been generated. Now if I'll go into the model, so there is two surfaces. One is the particular hollow out or hollowing out of this particular heart model that is concluded, and another one being the solid model that we have generated out. Now to see the internal features, what we need to do is we can select out any plane. And once this particular plane has been selected, I will select out this particular plane as one, clicking on it as active, and we can just slide it along, and we can check out the internals of the particular any anatomy that we are working. In this way, any structure can be created. And for example, if I need to create a four different parts model for this, what I'll go is I'll do in this options, and in this clip operation, instead of cut, I'll do the split operation, and the structure I would be selecting is this particular shell one. So I'll go into this, clicking shell, splitting, and execute. So it will split up along this particular plane region. Once it is done, we sorry. Yeah, once it is done, we'll go into the models, and in the model, so it has further splitted up the part. So I'll just toggle this off. So one part that we have is this one, and then another part that we have is particular this one. So I'll just disable the clip plane. Yeah, so this is one part that we have, and this is the another part that we are having. So this way we can split up it into multiple parts. So for example, if I need to segregate it into three different parts, now what I'll do is the particular split operation that I was having, I'll first rename it as one. I'll just rename it as A. And once I've renamed it as A, now I'll again apply the operation over here. So I'll select out another plane. Yeah, once I've selected this plane, I need to click on the operation, selecting the structure A, further doing the splitting. So this way, what we can do is we can have n number of clip operations, and we can split up the different parts. Once this is done, this enabling this particular part. And now what we can see is, I'll just delete this also, models, disabling this. So we have three structure model in a very less time, so we can easily see the internals of the structure. There's some need to be bonding to be done. So what we'll do is we can go to this active part, and then we can apply the region growing operation. So we can just select out the part. Sorry, I'll just undo this operation. I'll select the grow operation instead, selecting a less seeding, reducing out the size, and then slowly we can grow the particular any surface that we are required for. So this way the surface would remain intact, and we can do the particular wall marking very efficiently. So this way it can be carried out, and we can basically split up different parts. So for example, if I need to visualize only this part to see the internal structure more efficiently, can go over here, I can see the particular structure. And later on, even if we are required to do the 3D printing of the same, that too can be carried out. Apart from this, we have another sets of operation. that comes in the form of design. So design object, currently you will see there is an empty box. So why so? So we have the design object in my right controller. I can select over here. Here you can see there is an option of design. So what we need to do is we need to click on this edit one. Here we need to click on this create. For now, I'm just disabling this also so I can have an empty window. I'll just click over here. So here we also have an option to visualize whatever structures that we are marking in the 2D view or the particular 3D view. We can easily identify and distinguish it out how the particular marking looks like. So this way, any 3D or 2D can be selected out. And here we can also do the movement. So we can select a particular part, we can set it as movable, and then we can move from the active DICOM. So we can create a separate structure for the same. Coming on to the design part, I'll go over here. Since the particular design mode is selected, we can select out the type of surface that we need to design out. So for example, if we are required to design a rectangular prism, so that can be done. We can select out the length and width, and we can select out the depth. And here a particular design can be loaded in. We can also set it manually. So for example, if I require a 55 mm cross 100 mm cross 80 mm rectangular prism, so it can be easily constructed out. And if we are required to be working on this particular, if it's satisfying our needs, so what we can do is we need to click on this converter structure, and it has converted it into this particular structure. Now if we go into the model, so we can also see the converted design objects over here. We can enable and disable it. Then if we need to do a particular movement, so that can be done. We can set it as movable, and then we can just move it. We can just select it. Once it is selected, we can just move it along the particular axis. So what we need to do is we can just place it anywhere that we are required for along the part. So this is the basic design that we can do. I'll just delete it for now. Apart from this, the best option that I look forward in this is either to create a loop or any tube that we are required. So we can set out a number of control points, and we can set out any type of loop that we are required for. Similarly, if we need to remove any point, that can be directly selected out, and any structure can easily be erased too. The best tool is the surface tool. So we can select n number of contact points. Once it is done, we can map out the surface. So even if we are designing for any orthopedic part, so that can be done. If we need to design baffle, so that can be carried out. We can easily reduce out the dimensions. We can set it out accordingly to the particular surface. So how to do that? I'll go to this particular part. If I need to model it along here, I'll just first delete this particular existing design. So for example, if I need to focus on, let me just move. I'm just disabling this one also. For example, if I need to design any design for the specific structure, what we can do is we can click on create new surface, and then we can set out a number of control points. So we can have the most precise of the surface to be created out. What we need to do is we just need to add number of couplers. Once the coupling points have been selected out, we can mark it accordingly, and it's 100% correct as we are directly marking it in the 3D view. So we can add one more point. So for example, if this was our required surface, we can just convert it into surface. We can map that out, and we can also, if required, we can change the dimensions. We can reduce out the surface. We can also follow it out. There are multiple options. Apart from this, we are also having planning tools. For example, if we need to develop any stent, that can be directly selected. We have large number of library from which we can do. Once it is done, we need to click on enable, and once it is enabled, we can directly work on this particular part. You can just click over here. Sorry. So in the planning tools we'll go, we can increase the length, we can increase the width. Then we can also check over here. We can, according to the difference view plane of where we are marking, we can mark it accordingly, and the designing can be directly be carried out. So this is one such approach that we are having. Then we can select any type of selecting the part that we are required for. dimensions, and once it is done, we can easily set out. So it's still in the beta release that we are working in, but we can also reduce, sorry, we can also reduce the flare from the both the ends that is required for, and this way it can be carried out. Apart from that, we have the collaboration window. So even if multiple users needs to connect in a single view, they can be connected. They can also enable their voices. Then if someone needs to annotate any specific point, so he can either write it as a text uh, for the specific point. So if the particular requires to mark out the specific window, I'll just click over here and mark the particular ST. And once it is marked, so the text can be visualized over here. The particular user who has marked up is that can also be seen. If we need to add a voice input, so we can just whatever now I'm saying, it gets recorded over here. And once we click on stop recording, it will get recorded as it is. And whoever needs to play, when we'll go into engaged window, we can just play it, and we can just hear it. Even if we need to delete, we can do. So there are multiple options that we have over here. Then in the right hand also, we have the measurement option. So we can measure from one point to another directly in the 3D view. We can have multiple measurements to be done. Then if even if we are doing, we are segmenting it out into multiple parts. And then further selection can be done of each and individual part. And then we can do the marking to carry out the surface details, to carry out the surface volume information that can be done. For that, we'll go solid file structure, and if I need to do the structure detail, I'll just enable this particular part and removing all the particular measurements that I'm having. So here we can select out the active surface. Once I'll just select it out as clear all active surface. I'll remove out all the points that aren't required. And once it is done, we can easily export out the particular reports also. So these are the parts that we have using VR. We can do the segmentation very easily. And the same task, uh, somewhat of the same task can also be done directly through the image panel section. So whatever operations that we have performed using the particular VR-based segmentation, that can further be carried out in the 2D view tab. So we have the coronal, sagittal, and axial views. And furthermore, the segmentation can be done. Here, for creating the models, we have this structure option wherein the structures can be selected out. Whichever part that we were working, we can highlight that out. Whichever is not required, we can unhighlight it. So whatever operations that we were performing, it gets done in the same way in this view. For example, if I'm just disabling all the parts that we are having, and now if I need to directly do the segmentation from the 2D view tab, we can just click over here in the threshold window. We'll select out the active threshold range. And here we have an option. So you can see there is a shift within the data set. It's because we have selected the primary as secondary as different. I'll just select the secondary data set, and now it gets resorted. So we can easily mark up the boundaries. For example, if I need to mark the iota, so I'll just select over here. I'll select a new structure, high, and now whatever new structure that we have selected, we'll just select that particular part out, and then we can mark up the region. So now you can see whatever region that I would be marking that's visualized over here, we can mark up in the other views too. We can highlight the specific parts out, and the segmentation can be done in a very efficient way. So you can see whatever changes I'm doing in the particular 2D view, I can visualize the same in the 3D view. So that too is one such possibility that we have. And so now whatever region that we have marked, we can just go and we can check over here. So the modeling can both be integrated from the 2D view image dataset as well as 3D view. Apart from this, we also have an auto segmentation method. So we will go in this remote segmentation tab. Here we have the auto segmentation for any part that we are required for. For example, if we are interested in the cardiovascular segmentation, we will just we'll select the modality, whichever is required. And it takes around 5 to 10 minutes to do the segmentation. Once it is done, it will further split up the parts into all the required regions, and then we can further efficiently mark up the boundaries. We can smooth out the structure, And later on, once the segmentation and all the particular procedure is completed, we can export out the structure. So whichever is part is selected, for example, this was the particular three different parts that we have segmented out. So we just need to click over here. We can export it. We can select the folder, selecting the file type. Once that is done, I will, for example, create a new folder, P1, P is fine. I'll just select out this folder, and whatever parts that we have selected, we can easily export it over here. So this is one such efficient way that we get. Once the exporting is completed, we can check the particular folder. So these are the STL files that have been created. So even if we need to visualize in the 3D viewer, that can be done. So if we are basically generating a four-sectional model, so it gets generated in the quickest way. This is the quickest software that we can generate that out. And later on, if any magnets and all are required, that can be done. I do have one example I'm just showing that we have done the 3D printing for. Just switching on my camera. So to show the its practical applications. So this is our four-sectional model that we have of heart. So it's magnetically connected. So we have created magnetic connectors. It's a four-sectional model. It was used to identify the VST defect over here. And once it is done, we can just connect and disconnect the models, and the segmentation can be done in a quicker time, around 2 to 3 minutes. So this way, how we can practically implement the software for any application area. Till now, if anyone has any queries, you can just ask. Meanwhile, let me see. Yeah, so these are the different parts that it has highlighted out for the segmentation. If we are required to do smoothing of any part that can be selected, we can select all also once. So we'll select a global smoothing, and we can just do the import. And now whatever parts that have been selected out will easily get segmented. So this is the auto segmentation tab that we have in Illusis that's recently included. Furthermore, whatever parts that we were selecting gets highlighted out. Since it's uses total segmenter code for doing this auto segmentation, so the surface might not be that clear. So the best approach is, once the segmentation has been done, we can go to the specific parts, we can grow the specific regions, and once the region growing operation is done, we can carry out the smoothing, and after that we can furthermore work on the specific part. So this is a general view that we can work on. We can check over here, and to move out a particular scenic visualization, we can also show along the particular radiograph. We can also design new planes along which we need to do a particular cut section. We can just select it over here. So whatever task we can do in a particular VR, we can also do the same in image panel, but it's much more easier to work in VR as comparison to the particular normal image segmentation views. So this is all from my side for this soft tissue segmentation. If anyone has any queries, you can just let me know. Yeah, any queries, anyone? The session is open for question answers. I'm also sharing my contact details, so if there is any requirement regarding the tool, or if there is requirement of one-on-one demonstration of software, if you need to see on any specific case, rather being orthopedic, cardiovascular, you can just call me or text me over here, the WhatsApp, and we'll stay connected over there. So please, session is open for questions. Yeah, data annotation is possible using this. You can do the data annotation. Any further questions? So what we can do is we can provide a trial link of the software, but the hardware needs to be at your end. So you need to arrange the VR headset and a hardware compatible with the following settings. You can just drop in a mail, sir, and we'll connect with you for whatever's the hardware settings that are required and how to use the trial version. I think already the form mail is, yeah, sure, sir, we'll connect with you. Just dropping my contact once again. So this is my WhatsApp as well as my calling number. So anyone who is interested can text me. So thank you everyone for joining. Any further queries, or we can just wrap up the session. We'll be organizing more such session, focusing on specific parts. Like this was for cardiovascular. Next one would be for any orthopedic or oncological data set. So this is just a start that we are trying to develop the software for. And if anyone has any specifics, sure, sure, Dr. Rahul, I'll just figure out some way to have one week session. I do have a couple of recordings in my of my earlier sessions. I'll share with you so you can have a quick look how to navigate across the software. I so no further questions, I guess. So it's a wrap from my side. Thanks everyone for joining in. So I'll be further sharing more such webinar details. You can also follow us on LinkedIn. So you'll be getting all the notifications of the upcoming webinars. So once again, thank you everyone. I'm just wrapping this session.